Okay, this is requirement that we need to know before we move into the next topic of integration with changes of variables. Um, so we need to know matrices and determinants. If you're pretty good at matrices and determinants, you can skip this. Um, I don't think I'm going to show you a lot more than what you already know. If you are familiar with matrix multiplication and determinants. So a matrix is well, a 2 by 2 matrix is an array of 4 numbers. It is understood that we use real numbers, and sometimes we use sets that are not real numbers. So we're going to assume we have a 2 by 2 real matrix, which means we have an array of 4 real numbers. Um, so A, B, C, D. The symbol we use sometimes is the round bracket, sometimes it is a square bracket. I don't think it matters. Um, and we have to have 4 elements in here. One or more of the elements, the entries, could be a variable, but we may not leave any of them blank. We have to have either a number or a variable or some kind of expression, but we may not leave any of them blank. Um, so, so there, that's a 2 by 2 matrix. We are gonna multiply 2 by 2 matrices by 2 by 1 matrices. So if you have, this is a little bit informal, just a quick review. Um, so if you have A, B, C, D, we may multiply by 2 by 1 matrix, X, Y. So again, this is a 2 by 2 matrix. This other matrix is a 2 by 1. So 2 rows, 1 column. The first number tells us the number of rows. Second number tells us the number of columns. So 2 rows, 1 column, rows go horizontal, columns go vertical. And the way we multiply this is the first row. If you think of, of this as vectors, we have 1 and 2 vectors, A, B, a 2-dimensional vector, C, D, another 2-dimensional vector. And multiplying those 2 matrices produce a 2 by 1 new matrix, so only 2 entries, 1 on top, 1 on the bottom. And the top one is the dot product between the first row and that column. So AX plus BY. And then here we have CX plus DY. CX plus DY. Mind, this looks rather long, but it is just one entry. So let's say we have, as an example, example 1, let's use prime numbers 2, 3, 5, 7, and we want to multiply by, well, let's keep doing more prime numbers, 11 and 13, and see what happens. So we're going to get fairly large numbers. So 2 times 11, 2 times 11 plus, because that row multiplied by with this column, 3 times 13, 3 times 13. Let's compute that after we figure this out. 5 times 11, 5 times 11 plus 7 times 13, 7 times 13. And that's going to give us, let's see if I can figure this out. That's 39 and 22. 39 and 2 would be 41, and the 20, 61, if I'm not mistaken. And then 55, 7 times 3 is 21, carry 2, so 91 plus 55, 91, 96, 146, if I'm not mistaken. I just did that on my head. So that is how we multiply a 2 by 2 matrix by a 2 by 1 matrix. This is an intermediate step to figure out the actual answer. The answer is 61,146. Okay, so that is a 2 by 2 matrix. And 2 by 1 matrix and the multiplication between the two. A 3 by 3 matrix, so let's talk about a 3 by 3 matrix, is a matrix A, B, C, D, E, F, G, H, I, with 9 real numbers made up by or arranged in 3 rows and 3 columns. And we have to have all of the entries. And we may multiply by 3 by 1 a matrix, Y, Z, and that's going to give us, again, and we're going to end up with 3 elements, top, middle, bottom, and that is going to be a 3 by 1 matrix. So in this case, we will have A, X plus B, Y plus C, Z. And then the second element in the matrix will be DX plus EY plus FZ. And then we have GX plus HY plus IZ. Now, all of that gets consolidated into one number because we're adding all of those products. Just like here, that was 4 numbers. We multiplied 2 and 2, and then we added the corresponding products. Same thing here, except that we're going to add 3 products. Yep. I'm not sure it is necessary for us to do an example of this. It would be just the same as that, except that we will have 3 rows. Each row will have only 1 element in it. So let's move on to determinants. The determinant of a 2 by 2 matrix is denoted. Okay, so the determinant of the 2 by 2 matrix. So here's the matrix A, B, C, D, close parenthesis, is denoted by, we use the same bar as the absolute value, and then we place the elements in the matrix in the same order, in the same arrangement inside this 2 bars. So we have A, B, C, D. So that's how we denote the determinant of this matrix. And its value, and it is defined by AD. So multiply the diagonal, this is called the main diagonal, and subtract the other diagonal, the product of the elements in the other diagonal. So AD minus BC. There. So that's it. That is the determinant. I could probably go more into it, but this is a more of a practical thing we need to review very quickly before we go into multiple integrals with changing the variables. There's more to this, though. We need to know how to do 3 by 3 determinants. So that's the 2 by 2. I can perhaps give an example. example 2, let's say you want to find, so evaluate the determinant. Again, let's use prime numbers 2, 3, 5, 7. If we want to figure this out, I mean, here's the question, the end of the question, and then we can simply just write equals and provide the answer immediately. 2 times 7, 2 times 7 minus 3 times 5, 3 times 5. And that would be equal to 14 minus 15, which is -1. So that is the determinant. Yeah, the determinant is -1. This is the way we denote where it came from, but it is -1. All right, so now what about a 3 by 3 matrix? So if we have now A, B, C, D, E, F, G, H, I, and we want to find we want to figure out how to obtain this. You can start with the first row, write down A, and by the way, we're going to define this matrix based on the previous size matrix, which is a 2 by 2. We may only do determinants of square matrices, 2 by 2, 3 by 3, 4 by 4, and so forth. So A, start with A and move on to, okay, so you gotta watch, pay attention to this, please. If you start with A, then pretend you don't have the row or the column that contains A. And you're gonna end up with the elements E, F, H, I. E, F, H, I. So that's the first term of the addition of things we need to put together to obtain the determinant. See, here we had only 2 things to add together. Here we're going to have 3. So A times that determinant minus B times the determinant obtained by assuming that the column that contains B and the row that contains B is not there, so you end up with DFGI. DFGI. I wanted to add the other term here, but it doesn't fit, so I'm going to continue underneath, plus C, so ABC, ABC. And then we have, again, take off those, and you end up with DEGH. DEGH. All right. So that is equal, if we continue with this. Now remember, this determinant is EI minus FH. But then we're multiplying with A. So we have A EI minus A FH. So we have A EI minus A FH. All right, and the same thing will happen here. B times DI minus B times DI. Now, the reason why we have a minus is because this has a minus. And so when you start with this row, when you use this row to develop the determinant, you alternate signs starting with positive, negative, positive. You can develop the determinant using any one of the rows or any one of the columns, keeping in mind that when we are developing the determinant or expanding the determinant in sub-intervals, determinants, you start with positive here and alternate going across or going down, and then going across and down again. So this guy is plus, minus, plus. This one is minus because the one above was plus, so, and we gotta alternate, and then we have minus, this was minus because the one above is plus, and then plus, and then minus, and then plus again, minus plus. I will draw a matrix of signs in a moment, but let's continue with this. So then we got to subtract. So we did di, and then we got to subtract fg multiplied with b, but we're going to subtract that after subtracting this. So there's going to be two negatives, and we're going to end up with plus b f g plus c dh minus c eg. There we go. So we're going to, at the end up with 6 possibilities, 1, 2, or 6 products, 1, 2, 3, 4, 5, 6. Up here, we ended up with two factors or 2 products that we are adding together. Here we end up with 6. If we had a 4 by 4, we would end up with 24, which is 4 factorial. This is the number of terms is 3 is the factorial of the number of rows or the number of columns, which is the same. So we got 2 factorial, 3 factorial, and so forth. So what we are really doing is taking a whole bunch of products. So A, E, I, and then A, F, H. So that's all the ones with A. And then B, D, I, B, D, I, yep. And then B, F, G. And then with C, we got C, E, G, C, G. But we could also have C, D, H, C, D, H. So what we are doing is taking all of these products are made up, but by taking one and only one element from the first row, whether you start with A, B, C, and then one element from the next row that is not in the column where the first element was taken from. So if you start with B, okay, there's the 2 that start with B. Then, and the reason why we have 2 is because the next multiplier, the next factor, will be an element on the next row that is not on the column of the B. So either D or F. There's the F. All right, so we went B, F. Then the next element in the product has to be an element from the next row, which is not in the column of the previous 2 factors. So not in the B factor, in the B column or the F column. So the only possibility is G. Yeah. So once you pick 2, the next one is unique. You cannot go, there's no choice. Once you pick 2, the other one is determined. So if you pick this one and this one, that one is determined. If you pick A and F, then H is determined already. Yeah. So once you choose the first one, there's 2 ways to go, and there is 3 ways to choose the first ones. So that's 3 times 2, and then 1, and that's how we arrive to 6 possibilities. The signs, let's see if we can view this. So A, E, I is positive, A, F, G is negative, B, D, I is negative, B, F, G is positive, and then C, D, H is positive, and this one is negative. So there's a little bit of a pattern going on here. Yeah, yeah. Let's do an example very quickly. So example 3, let's say you have 2, 3, 5, 7, 7. I don't want to go 2 digits, so let's go back to 1, 2, 3, 4. I don't want to use the same numbers too frequently either. let's go with a 6 for a change. Okay, so we want to find this determinant. There's a couple of numbers that are repeating, 2 and 2, 3 and 3. So that should be okay. If we do this with the first row, as we showed earlier, we have 2 times the determinant 1, 2, 4, 6. 1, 2, 4, 6. So why? So I'm starting with this row, picking the 2, and then assuming there is no row of the 2 and no column of the 2, and we end up with 1, 2, 4, 6 minus, and then go with the 3, the next one, and then 7, 2, 3, 6, 7, 2, 3, 6, and then add the 5, this 5, and multiply with the determinant 7, 1, 3, 4. 7, 1, 3, 4. Okay, so that is equal to 2, and then try to do this in one shot. There's no need to write everything. So 6 minus 8, that's -2, minus 3 times 7 times 6, that's a big number, 42, minus 6, that's 36, plus 5 times 7 times 4, minus 3. So 7 times 4 is 28, minus 3 is 25. So we got -4, minus 3 times 6 is 18, carry 1, 3 times 3, 9, and 108, plus 125. So we have -112 plus 125, and that is one of my favorite numbers, 13. Okay. Again, now I did say we can use any row or any column. So if we use this row instead, we may. Now, there is a chart of signs assigned to a matrix when we are developing a determinant, plus, minus, plus, minus, plus, minus, plus, minus, plus. So if you are using an element in this position, use the plus. If you're using an element in this position, minus, an element in this position, minus. That's why here in front of the 3, we have a minus, because the 3 is in this position, so we use a minus. Now I'm going to develop the matrix, the determinant rather, using this row. So if I start with the 7, this 7 is attached to a -7. If this 7 was a -7 to start with, then we add another negative, and that will cause it to be positive. Anyway, so we have 7 times 3, 5, 4, 6, 3, 5, 4, 6, plus 1 times 2, 6, 3, 5, 2, 6, 3, 5, minus 2, and then 2, 3, 3, 4. 2, 3, 3, 4. And that's going to give us -7. 3, 6 is 18. 18 minus 20, -2, plus 1. I'm going to put it there for the record. 10. Wait, this is 1. The matrix, the determinant that goes with 1 is 2, 5, 3, 6. I think I switched those by mistake. Good thing I caught that. 6. 2, 5, 3, 6. So we end up with 12 minus 15, -3, minus 2, So 8 minus 9, negative 1. Hopefully this will, because we're supposed to get 13, 14, take away 3, but then add 2 back to it. Sure enough, that gives us 13. Yeah. In practice, let's do it one more time. 2, 3, 5, 7, 1, 2, 3, 4, 6. And we want to find the determinant of that matrix. In practice, this is how I go about it. Let's say I take this column. If I expand the determinant using this column, I kept using developing, but I think expanding is a better choice of a word. So this 5 I know has a plus, so start with plus 5. There's no harm done if you put a plus to emphasize. And then I don't even write the other determinant, I just do it in my head. If the numbers are easy enough, they're all positive. If you have negatives, you gotta be a little more careful because you gotta keep track of the negatives. There's a lot of negatives involved because we're doing, for instance, 28 minus 3 is 25. There we go. And then the next number that I'm gonna use is 2 minus 2. And then I do again this determinant in my head. 2 times 4 is 8 minus 9, negative 1. And then plus 6, 6. And then that goes with, so we could do plus, minus, plus, yep. And then 2 minus 21 is negative 19. So we end up with 125 double negative plus 2 minus 6 times 9 is 54, carry 5. 6 times 1 is 6, and 5 is 11. So we have 120, whoops, scratch that, 127 minus 114. 7 minus 4, 3. 2 minus 1 is 1. Sure enough, we get 13. So in practice, this is the way I figure things out. I double check though to make sure. Sometimes if I'm not completely sure, I do the determinant in 2 different ways. Yeah, the accuracy, especially when you have small numbers like this, is important. Now, there is a way to do this with a graphing calculator. You can enter your matrix on a graphing calculator, and then you push 2 buttons. After you enter the matrix in your graphing calculator, and then you push about 2 or 3 buttons. It's very quick, and the calculator takes like half a second or less than that to give you the answer. When you have matrices that are this small, it is good to become familiar with the mechanics of how to get it. Reserve the graphing calculator for matrices that are huge, that are big. Yeah, it is. Otherwise, you're abusing the technology. I guess there's no harm done if you check your answer with a graphing calculator. Yeah, that is a good thing. But you should do this kind of computations by hand. They're simple enough that and we don't need to use technology, advanced technology for this. All right, this is a quick, brief, fast review of matrices and determinants.